Hey Mike, come here. This has to be it, Mike.
Come on, let's open it.
Okay, we shall bring it back.
Planet Earth, home to over 7 billion humans. This number is expected to continue growing to 9 billion in year 2050. Consequently, this leads to ever-increasing energy demand. Over the last 200 years, a large proportion of our energy came from fossil fuels. Petroleum, coal, and natural gas have been the primary source of energy for centuries. However, these non-renewable resources have finite amount and it is only a matter of time before they run out, not if. So what other options do we have? The answer is none other than from nature itself. Science has provided us the knowledge to harness energy from greener sources such as from the sun, wind, wave, biomass, and from the heat of Earth itself. In recent years, the renewable energy boom has been caused by increasing oil prices, and wind energy is leading the pack as the fastest growing renewable energy source. So what makes wind a cut above other green energy sources? Firstly, wind generates energy at any time. Nearly all countries have windy areas. It does not produce greenhouse emission, and it is a source of clean and cheap energy. The wind played a long and important role in the history of human civilization. Since early recorded history, people have harnessed the energy of the wind. The first known use of wind dates back 5,000 years ago, where Egyptians made the earliest known sailboats, using wind to propel boats along the Nile River. By the 6th century AD, vertical axis windmills were used by Persians to grind grain into flour. New ways of using energy from wind eventually spread around the world as returning merchants brought back this idea to Europe. The first horizontal axis windmills appeared in Western Europe and were used to drain fields in Netherlands. In the 18th century, American settlers began using windmills to pump water for farms and ranches. By the 1940s, fuel prices dropped after World War II, causing loss of interest in wind turbines. In 1973, global oil embargo caused interest in wind energy to resurface. Since then, the development of new wind turbine designs began. In 2009, wind power generated 2% of worldwide electricity usage, with the potential to grow even further. If you place an object, like rotor blade, in the path of wind, the wind will push onto it, transferring some of its own energy of motion, causing rotational motion of the rotor. The rotor turns a shaft, which transfers the motion into a nacelle. The slowly rotating shaft enters a gearbox that greatly increases the rotational shaft speed. Then, the output shaft is connected to a generator that converts the rotational movement into electricity at medium voltage. Electricity flows to a transformer via electric cables, which increases voltage of the electric power to the distribution voltage. The distribution voltage power flows through underground lines to a collection point where power is combined with other turbines. Electricity is then supplied to nearby residential areas. Electricity may be also sent to a substation where the voltage is increased to transmission voltage power and sent through national power grid to distant cities and factories. Firstly, offshore wind turbines do not require land and thus prevents land issues for its establishment. Secondly, it brings less harm to wildlife as thousands of birds die every year by flying into onshore wind turbines. For example, in Altamont Pass, California, where 1,300 birds are killed each year due to a wind turbine constructed along a critical migration route. More electrical power can be generated offshore as there is more wind compared to onshore, as wind over the ocean is less turbulent due to lack of obstruction at sea. Lastly, it is due to aesthetics factor. Offshore wind turbines come into less contact with humans, so they do not need to deal with noise pollution. There are two types of offshore wind turbines, which are fixed and floating wind turbines. Fixed wind turbines stand on concrete foundations driven into the seabed, making it very difficult to be installed in deep sea. They must also be built on site. Not only that, fixed foundations are dependent on depth and seabed condition, causing each fixed foundation to be different from the other. On the other hand, floating wind turbines can conquer deeper oceans and hence can harness the strongest winds in the world. Floating wind turbines are also fully manufactured onshore, towed, and anchored at the required location. Every unit is also similar in design, thus reducing costs.
It looks like the Malaysian water are to be anchored with a few fans to cool its citizens who are currently sweating due to the hike of the fuel price. Oh, okay, my mistake. It was clearly understood here that the fans are actually wind turbines aimed to replace the non-renewable energy system in this nation.
A few locations has been identified to locate the wind turbine. To begin with, Kota Baru, Kerteh, and Bromping.
As we move on to East Malaysia, Lundu, Matu, Bintulu, Miri, Lawas, Tuaran, and finally Kudat are feasible locations. As you can see, all the locations mentioned for turbines are facing the South China Sea. This is due to the factor of constant wind flow throughout the whole year. At all the stations listed, the wind energy generation can be higher in the northeast monsoon period. As the wind is strongest during this period, the wind speed varies from 2 meters per second to 13 meters per second from season to season. Hence, a wind turbine with a minimum wind speed of 2 meters per second is capable of generating electricity all year long.
There's so much more potential to develop wind energy. Researchers are currently testing hybrid prototypes that can harness energy from both wind and tide, which may be applicable in large scale in the near future.
Mike, that was informative.
Yeah. Hope this will help us to produce a greener and cleaner energy.
Oh my god, not again.